All right, so let me try to explain where I got this multiplier formula from. So again, I have y prime plus pxy equals to qx. What I'm trying to look at is a function, some magic function. When I multiply to the entire thing, the left side turns into the product rule. Okay. That's my aim. So I multiplied m of x to all the terms I see, and my goal is to make this into a product rule. Okay? Now, from that previous example that we've seen, we see that if this was to become a product rule, it probably should be the derivative of m of x y prime. Okay? Because think about how you would apply the product rule to this. You differentiate the second one so that you get y prime, and m is untouched, so you get the exact same thing, right? So if somehow this thing magically also turns into the other one that appears from the product rule, then all is good. We can integrate both sides and we can solve the differential equation, right? So that's my goal. I want the left side to be in this form, okay? Okay, but now let's actually do the computation of this one and compare it to this and see what we really need. So if I apply the product rule, this is mx times y prime plus m prime x y. And then comparing the top and the bottom, we see that m prime of x should be what? For these two to be exactly same equation, m prime must be what?
mxpx.
mxpx. Okay. And then we're almost there. We're almost there because now I can divide by mx. And then integrate both sides by dx. And then set u equals to mx to do the integration of the left side. If u is mx, then du is m prime x dx, so that this top part becomes du. The bottom one is 1 over u. Okay, so this left side becomes integration of 1 over u du, which is ln of u. And if I replace u by mx again, I get ln of m of x. So what I get is ln of m of x equals to integral of p of x dx. And then I solve for m by raising it over e. And that's where I get this formula. M of x is the integral of px dx. So this just naturally appears if we impose the condition that after multiplying mx, the left side has to turn into a product rule. Okay? All right, so let me have another question that makes use of this formula. Let's put a second example. Right, this time, let's write it as x y prime plus 2y is equal to x squared. Let's try to solve this equation. Okay. Now, there is one thing that you have to be careful when you apply this form. We derive this form by assuming that the original differential equation was given in the form of y prime px y equals to q of x, right? So you can't readily apply this formula to here unless you put it into this form. In other words, what spoils this is this x here. Because there's this x in front, you're not allowed to you're not allowed to use this formula. So what should we do?
Divide by x.
Divide the x all around. Okay. And now you have y prime plus 2 over xy equal to x. So that's the first step. When you try to apply the multiplier to solve, first see if you can get it to look like this form. Okay. Right. This is still, before dividing by x, this is still a first order linear differential equation because y prime, y do not have other powers. This is power 1 and they're not multiplied together. So this is first order linear differential equation. However, in order to use this formula, you have to get rid of the coefficient function of y prime. So you have this. Then your px is 2 over x, right? So now let's calculate that. M of x is e to the integral of 2 over x dx, which is e to the 2 ln of x. And it's really, you have to multiply that there, so it's e to the ln of x squared. I hope you know this rule where the number in front of the log can jump over the log like a frog. I like to call this the frog over the log rule. So if you have log and a number in front, it jumps over the log. It comes here. I like that because then, with nothing in between e and ln, they can just decimate each other, and you get x squared left. Okay, so you know that x squared is the thing that you have to multiply both sides in order to get a product rule on the left side. Okay. All right. Another thing that you have to be careful here is when you get this multiplier, you have to forget that it came from here. You don't multiply x squared to the original equation. You multiply the x squared to the new form that you made. Okay. Because this only applies to this type of form. Okay. All right. So I'm going to multiply x squared both sides. I get x squared y prime plus what do you get if you multiply x squared times 2 over x? X and one of the x cancels, right? So what do you get? 2x. And x squared times x is x cubed, right? And now you have x squared y prime as the left side and x cubed as the right side. Okay. Now I went to this one rather quickly, but by now you should understand that really, if you, after you multiply the multiplier both sides, if you have firm faith, like a religious faith, that the left side is a product rule, then you can just take this part and just get rid of this y prime, and that's what should go inside this parenthesis. Okay? Just whatever you see on here, just remove the prime and then just put parentheses like that. Okay? And if you're not unsure, if you have doubts, then just like you have to go back and read the Bible. Yeah, you can just take this and apply the product rule. Okay, and then let's see. You differentiate. Now you integrate both sides by dx. And then derivative and integration cancel. And 1/4 x to the 4th plus c. And finally, you divide by x squared, and you get and that's your final answer. Okay.
Wait, where did the prime thing go? Outside the
This prime cancels with integration, right?
Oh, it does?
Yeah, if you differentiate and integrate, they cancel. So that's why you. And if you actually apply the product rule to x squared y, you really do get this on the left side. So x squared y prime, differentiate the second, differentiate the first, and this differentiates too. So you indeed get this. I mean, once you are really experienced, then you don't have to calculate this. When you're given this problem, you can actually look at this and say, hey, how do I get 2? Oh, maybe if I have x squared, then 2 can come front. So I'll just multiply x all across. Then the left side will become a product rule. You can actually just see it and decide that x is what I want to multiply in the original. At some point, you can do it like that.
How long you think?
If you teach differential equations for maybe 5, 6 years, then you see it and you see, oh yeah, that's how it works.
All right, nice.
But if you haven't taught differential equations for 6 years, then probably this is what you should use.